All right, good morning or afternoon, whatever time you're watching this. Algebra 2 students, this is chapter 8.2, graphing rational functions. Okay, so let's start real basic, sort of review everything as if you had forgotten everything. Okay, first thing to notice is rational, the word is ratio. So a ratio is just a comparison of two numbers. 3 over 2, that's a ratio. Or just any fraction. Ratios are generally written as fractions. Okay. So that's why some math teachers will tell you to think of it as fractional. Okay, that's all it is. We added an F and a C, and rational becomes fractional. And it helps you remember that, oh, okay, it's those ones that have fraction. Okay, but not anything that has a fraction. The key thing here is that if you have something like this, okay, the 1 over x, that is a rational function. And we're going to try and graph stuff like that today. Okay, so anytime we graph something that we're not too familiar with, what you want to do is make a table of values. Okay, so like for basic equations, table value works great. Okay, what we're going to focus on here is a couple things. If we were going to make a table of values here, we should try some negatives and some positives. Okay, and this is pretty much straightforward because we can't get a much easier rational equation. There's just a 1 and an x, that's it. So when we plug in -3, we get 1 over -3. When we plug in -2, we get 1 over -2. When we plug in -1, we get 1 over -1 or -1. Here's the problem. If you try to plug 0 in there, 1 over 0 is undefined. Okay, so something weird is going on at 0. Okay, we'll come back to that. That's critical. In fact, I'm going to go ahead and highlight that key information. This is critical about this chapter. Undefined. Okay. When you plug in 1, it's going to be 1 over 1, which is 1. Plug in 2, it's 1 over 2, which is 1/2. Didn't even need to rewrite that. And 1/3. Okay. So we got a few points. Let's go ahead and see what the graph turns out like. And if you're going to graph, you want to make sure you have a nice straight graph. And if you don't have a ruler, then use anything that's straight. Today I'm using my cell phone. That's a little bit too dark. Oh well. I don't feel like redoing it right now. So here's what we got. Let's plot our points. 1, 2, 3, -1, -2, -3. So -3 and then -1/3. So we go over to -3 and then down about 1/3. So this is -1. It's not even 1. It's 1/3. -2 across -2 and then down 1/2. That's a little bit lower. And then -1, -1. So we go across -1 and down -1. So all of these points, again, they're just, all these things in our table of values are just coordinates for different points. Okay. Now we don't know what happens at 0. We'll come back to that. We just know it's undefined. Okay. What we do know is it's sort of, if we connected those points here, it's sort of curving. Okay. It's not straight. It's sort of curving. Okay. And if we continue the rest of the points, 1, 1, across 1, up 1, and then 2 and 1/2. So across 2 and then up 1/2, and then across 3 and up 1/3. Okay. So what we got to do here is sort of find some more points. This just isn't going to be enough. Okay. What does look like is going on here is getting smaller and smaller. So let's go a little bit farther out. 4, 5, 6, 7, 8, 9, 10, let's say. All right. And if we put in 10 into our table values, we'll get 1/10. That's really small. Okay, so what's going on here is 1/10 will be way over here, really small. It's just getting smaller and smaller and smaller and flattening out here. Okay, so it's getting flat there. But what about in between here? That's where the interesting stuff goes on. We don't know 0, but we can try and get close to 0. So if we put in 1/2 into our function, halfway, what happens is, into our function we get 1 over 1/2, which by our rules of division of fractions, the numerator times the reciprocal of the denominator. 1 times 2 over 1 is just 2. So 1/2 actually put us all the way up here at 2. Okay, so it's shooting upwards. Let's see if we can continue that. 1/3. 1 over 1/3. Same thing, numerator times the reciprocal. We get 3. So it's even goes smaller here, it's going even higher here. So the whole key feature of these functions for this chapter, they'll shoot up to infinity at one spot, usually, and they'll flatten out somewhere. Sometimes at 0, sometimes somewhere else. Okay. The other thing is these things have symmetry. See if you can, if this makes sense and we agree with this. What happened at 1/2 will be the same thing at -1/2, just on the bottom side. Okay. If you don't believe that, I'm going to continue my table of values here so you can see it. If you plug in the -1/2, you're going to get 1 over -1/2, which is 1 times -2/1, which is -2. So it does go that way. And if you tried more points, you'd find it going really close this way. And same thing over here. This one does the same thing it did on the positive side. So here's what's going on. Critical stuff here. We knew it could not come through 0. 0 was undefined. So you'll notice at 0, it never touches the point x equals 0. X equals 0 is the whole y-axis. It never touches this. And there's what we call an asymptote. Okay. There is an asymptote right there. Okay. And it will not cross that vertical asymptote. That's what's going on here. Okay. So the key thing is these functions are going to have asymptotes. Okay. And why was there asymptote? It was all about this. We cannot have the denominator equal 0. If it happens to be 0, it's undefined. The whole thing falls apart. So we're stuck. So hopefully that helps. In part 2, we'll talk about what happens if you have something other than x, like x plus 5 or x minus 2. Okay. Part 3, we'll talk about what if you have an x on top and an x on bottom. Okay. They're all part of the same family of functions. Okay. So that's why some teachers call this the mother function. All right. Because this is the parent function or the mother function. Put in quotes because it's not a real math term, but it helps you remember that. The whole thing, like I said, is they're all going to be similar to this. They're going to have vertical asymptotes. They're going to shoot up to infinity or shoot down towards negative infinity at that asymptote. And they're going to look something like this. Okay. The actual points might change, but the general shape is going to be very similar. All right. Thanks for watching, and tune into part 2 for the next level of this type of equation.